So this is chapter 2. In this chapter, we're going to look at some basic tools and concepts that we'll be using in forecasting or when we apply forecasting models in the future chapter. So this chapter covers some basic stuff. The kind of things that we'll be discussing are some theoretical stuff like types of data and the different kinds of time series plots and scatter plots. We'll develop some plots in Excel, and then we will look at some summarizing of data and correlation between variables, and then we're going to be looking at some specific topics that are particular to forecasting, like some transformations. Why do we do transformations, and what kind of transformations in data are available to us, and how do you measure forecasting accuracy, and how do you develop prediction intervals for forecast. So these are basic concepts that can be applied in general to whatever forecasting methodology we may select for a particular data set. So these concepts will be relevant for all the different models that we'll be discussing in the future. So let's start with the type of data, and you can have three different types of data that may be available. Now, cross-sectional data is like a snapshot. Okay, that at one time, a single time period, you gather data about whatever that you're trying to analyze. So that will be cross-sectional data. Now, time series data, on the other hand, is data measured over a period of time at regular intervals of time. So weekly sales, for example, or daily sales, or monthly sales. And those are examples of time series data. Now, panel data are cross-sectional measurements that are repeated over time, such as monthly expenditures for sample of customers. So when you do the time series data, cross-sectional, but in the time series you're gathering cross-sectional data, so that will be panel data. Now, compare, when you're trying to do forecasting, you want to make sure that the data that you gather over a time period in a time series data, they're comparable data. So you cannot say, for example, gather data about family of product in one time period and then individual products in a second time period. And another way is you cannot have the first time period be 1 week, the second time period being 1 month. So those are inconsistencies that will make forecasting nearly impossible. So you want to make sure that the data that you gather are comparable data. The time periods should be of the same length, the units are of the same units, and the definition of what is being measured is consistently applied. So these are the things that we need to make sure that the data that we gather are comparable data. Now, the data may be an individual variable upon which we gather data, gather values. Okay, it can be 4 different types of variable, and these are categorical, ordinal, interval, and ratio. Okay, I'm sure that you've come across these terminologies from your stat class. Categorical would be groups where there is no inherent hierarchy among the groups, whereas ordinal is categorical, but the categories have a hierarchical meaning. Like some are like bond ratings. AAA is better than AA, and so on. So there is, even though these are groupings, there is a hierarchical ranking within the groups. Interval scale is one where the intervals are defined, or there. One other way of looking at interval scale is whether the 0 is defined at an arbitrary point. For example, when we measure temperature, 0 degrees Celsius is one particular level, 0 degrees Fahrenheit is something else. So these are defined by somebody arbitrarily. Whereas if you're talking about monthly sales, 0 sales means no sales. It doesn't matter who is defining it, it's always 0. So 0 has a absolute meaning that is not relative, and that would be ratio scaled. So data may also be looked at as a discrete value or continuous value. So discrete would be how many customers will call in a time period of 5 minutes. So it can be 0, 1, 2, 3, and so on. So that will be discrete. On the other hand, if you're looking at time period, so how long will it take before a second customer calls, or time between two customer calls? So that is a continuous variable. It can be greater than or equal to 0. It can be any amount. Okay. The times, or of course, we already talked about cross-sectional, whereas time series. And then we have stock or flow. Stock would be capital, flow will be income coming from capital. Okay. All observations are measured in finite degree of accuracy. So if you have 2 decimal places, 3 decimal places, 15 decimal places, so you need to have consistent degree of accuracy. So the variables may be discrete but conveniently approximated by continuous variable. For example, monthly sales of automobiles. Obviously, it is going to be a discrete value. But if the values are really large, then we can treat it like as though it is a continuous variable. Okay. Now, time series plots are the ones where we have x-axis is time period, y-axis is sales, and then you plot it. Then what you have is a time series plot. And we're going to look at several examples of time series plot. We'll develop those plots in Excel. Okay, so here are those examples, and we will look at them in more detail in Excel. So I'm just quickly going over these now, but we will be developing these plots ourselves. Okay, and then we have scatter plot, where you have one variable on the x-axis and another variable on the y-axis. We'll also look at these scatter plots in a minute. Okay, so we'll now go to Excel and develop these plots.